Hey chaps, I hope you're all well. So, the time has finally come. We're going to be placing some tiles onto the tile map today using the proper Tileset textures. Now, I am going to break this up into two separate episodes, contrary to as I suggested in the previous episode, just so we have two smaller chunks and makes it a bit easier to digest, because I realised it was getting a little bit complicated and long, so I wanted to make sure it was just as easy as possible to follow along and I didn't have to rush it. So without further ado, I'm going to get straight into this episode where we're going to be covering the actual loading of tileset data, such as frames, and then the ability to actually load those frames into the tileset previewer so you can see them live for yourself. Okay, so just a very quick whistle stop tour of where we were last time. If I crank up the editor, we have a combo box which has a list of loaded tilesets. Clicking on a tileset will load the tileset's image into the tileset previewer. The names of these tile sets is coming directly from the names of the files they've been loaded from, minus their file extension. For example, we have fulltileset.png, which displays as full tileset in the combo box. As I mentioned also in the previous episode, it's possible we're going to need to know more around these tile sets, such as where each individual tile or frame lives within the tile set, so we can then make a click selection of that tile to then paint into the map. And that's the first thing we are going to tackle today. So to get us started, the first thing we're going to need is a way of storing this additional information. And we're going to do that by creating a file alongside the tileset image to describe that tileset. So if I hop over to the File Explorer now, alongside our tileset images, I'm going to create a file which describes mini tileset, as that is a nice simple two-tile tileset to describe. So I'm going to right click here, new text document, and I'm going to call this mini tileset, spelled exactly the same as the tileset image, but I'm going to change the file extension to .json, which stands for JavaScript Object Notation. Don't worry too much if you don't know JavaScript or JavaScript Object Notation. It's just a relatively easy way of storing data, and you'll easily pick this up when you see it. So with that said, I've now created a file to describe mini tileset. What I'm now going to do is open minitileset.json in Visual Studio by dragging that into Visual Studio. And in here, I'm going to add a little bit of data which describes the mini tileset. Now, how this works and how it's going to work is through a process called deserialization, which will essentially mean that whatever I type into this file, when you see it in a moment, will turn into an instance of a tileset. So if I create an object here, which looks very much like a scope block in C#, I'm then going to add a name property, which will be encased in double quotes, and then I'm going to call this in another string mini tileset. So just like a string, I can have spaces in there, etc. But notice the name, okay? That name refers directly to the property in our tileset class. So when I go through the process of deserialization and it creates an instance of a tileset, the name of the tileset will become this. But we'll get to that shortly. The important thing is we've added this in here right now, so we can then use it to load the mini tileset. The next logical step for us to take is to start making use of this data. To use the data, we need to load the JSON file, and thus we need to change how we load tilesets. If we open the engine project and go to the Bootstrap class, in our load tilesets method, it currently just loops through all the PNG files it can find, creating an instance of a tileset based on the texture of the file and the name of the file itself minus the file extension, and then adds it to the list. Now we need to take into account the JSON file, so this is about to get a little bit more complicated. So what I'm going to do is move some of this code into a new method, which is going to live on the tileset and perform very similar to this texture2d.fromStream. So ours will look a little like tileset.fromJSON file. So let's create that method now. So if we head to our tilemaps tileset class, in here we're going to add a new public static method which returns a tileset and will be called fromJSON file. This method is going to accept two arguments. The first is a file path of the JSON file itself. The second will be a graphics device which will be responsible for loading the texture as it did in the Bootstrap. So we have our method. How do we load the JSON file? Well, we're actually really fortunate in that we already make use of MonoGame Extended, which itself makes use of a good JSON conversion library called json.net by Newtonsoft. So all we need to do is make use of the classes already available to us. So first we're going to need a tileset instance to store it in. And then we call JSON convert minute add the namespace control period using newtonsoft.json. And then we call deserialize object, go for the generic version, which you can specify a type on. And then the only argument to this method is a string value. This value is the entire content of the JSON, not the file path. So what we need to do is load the content of the JSON file before passing it in here. And we can do that really easy in our case. We can just call file.minute add the namespace, system IO, read all text, and then we pass our file path. And it really is that easy. That will take the JSON file, copy the properties where it makes sense and where they match. So name will become mini tileset in this case. However, there is nothing for texture because we need to do that separately. That is not stored in the JSON file. And that's why we passed in this graphics device. So how do we get the image file? Well, we know when this file path is passed in, it is the path of the JSON file. What we also know is the name of the image file is exactly the same as the JSON file, but with a different file extension. So what we can do is just simply change the extension. So if we create another string here called png path, and then we call into path.change extension, passing in the original path, and then our new extension will be .png. So here we now have our PNG path. So we need to load in the texture and add that onto the tileset instance. And to do that, we're going to look at our old code for doing that, over in the Bootstrap class. So if we open up the Bootstrap class, head down to our load tilesets, and we have this stream that's created here, so we can then set the texture. So we'll copy in this entire block here for now, go to the tileset, paste it a couple of lines underneath, and then remove what we don't need. So we have a stream which is created by opening a file. This path will now be the PNG path. We don't need to create an instance of a tileset as we already have one. So what we do need to do, however, is just set the instance's texture to this. So I can remove pretty much everything in here apart from this line. So let's remove all of that. And then set our tileset.instance, or tileset instance texture equals texture 2D from stream graphics device file stream. So here we have it. We have a file path passed to this method, which will be the JSON file path. We turn that into an instance of a tileset based on the content of that JSON file, which in our case only contains a name. So we'll have a tileset instance with a name and no texture. So what we then do is change the file path and the extension of the file path to the PNG, load in the PNG and set the texture on the tileset. The only thing we have left to do is return that tileset instance. Okay, so with that said, let's morph our Bootstrap to now make use of this new functionality. So head over to our Bootstrap class. In here we have a bunch of code which loads up tilesets based on their images, which we now need to change around. The first thing I'm going to do is just change this to now say JSON paths. So I'm going to right click on texture paths, rename. I'm going to call this JSON paths. And then of course change this to asterisk.json. So I'm going to go through each JSON path. I'm going to get the singular JSON path here. And at this point, I can just remove all code apart from this adding to the list, which I'll place down here underneath the using, delete the entire using block. And then in here, I'm going to create a tileset instance equals tileset dot from JSON file and then pass the JSON path along with the graphics device, which needs to be a lowercase g. Okay, so we have our code there. Now it's much more minimalistic and a lot of the responsibilities have been moved over to the tileset class. So let's have a quick step through and make sure this is working as we expect it to. Of course, we only created one JSON file, so now we only expect one tileset to be loaded. So I'm going to put a breakpoint here and give this a quick run to make sure it's working. So I'm going to hit start. Okay, so I'm going to step over this JSON paths and we should have one JSON path, which we do. Let's have a look at that, expand it, and of course it is mini tileset.json, which is exactly what we expect. So I'm going to step over it again and keep going. And then here we go through the deserialization process. I'm going to step over that. So now we should have a tileset which has a name of mini tileset with a space, which it does, and then we have the texture as well. I'm now going to continue and open up the editor and see if we have one tileset, which we do, and it has the string that I set in the JSON file. Clicking on that should also display the texture, which it does. So we have functional parity of what we started with, however we now have a new way of specifying data for the tileset that we can change without rebuilding the code. The next thing we need to think about is storing more information around these tilesets, more specifically the tiles or frames within them. And to do that, I'm going to head over to the File Explorer and open up the JSON file once again. So in the JSON file, I need to add a new property called frames, which is going to house the information for each individual tile frame. And to do that, I'm going to add a comma at the end of the first property, which is to separate the two. And then I'm going to type frames. In Visual Studio, if you are using Visual Studio, doing that and then entering colon will then encapsulate it in double quotes for you. So because frames is going to be an array of objects, an array is represented in JavaScript or JSON using square brackets. And then in the square brackets, we need an object for each frame or rectangle, which again is just like an object as we specified for the outer object. And then each rectangle is essentially made up of 4 components, the X, Y, width, and height. So I just need to enter each one of those as different properties. So the X, in my case for the first frame, is 0, the Y is 0, the width is 32 for 32 pixels, and the height again is 32. The second frame, I'm going to copy the first one, place a comma, and paste it. The second one is exactly the same, but the X is 32. And I can show you how that works out on the tileset itself. So let's have a quick look. So here's the mini tileset. The first frame starts at 0, 0 in the top left and is 32 by 32 pixels in size. The second one again is 32 by 32 pixels in size, but it starts 32 pixels along the x-axis, which is the horizontal axis here. So you can see that now becomes this tile here, the marble or the tiled version. Okay, so that is our tileset frames set up in the JSON file. The next thing we need to do is load that up into the tileset class, which is actually a lot easier than you may think. All we need to do is add another property, public list rectangle, and then this is just going to be a list of rectangles called frames. Okay, you may need to add the namespace for that one potentially. Okay, and that's all we need to do. So if I add a breakpoint at the end of this method here where we return the tileset instance, give that a quick run, and we should have 2 frames loaded up into our tileset instance. So hover over tileset instance here, we have a mini tileset, which is correct. We have a texture, and we have 2 frames. In here we have 2 rectangles, 0, 0, 32, 32, 32, 0, 32, 32, which is exactly what we expect. So now we're loading up the tileset information and we're loading up the individual frame information. The next thing we're going to tackle is drawing these individual frames in the tileset previewer. But before we do that, we need to change how the tileset previewer handles tileset information. So if we head over to our tileset previewer over in the editor project, under controls, right click and view code on the tileset previewer. In here you'll see we have a single image property representing the image on the tileset picture box. The problem with this, however, is that we have no knowledge of the tileset or the tileset frames, so we couldn't possibly draw the tileset frames over the top of this image. So what we really need to do is start accepting the whole tileset and let this previewer worry about setting the image. So to do that, I'm going to first create a backing property for it. So a private tileset, may need to add the namespace, control period, add the namespace, and then add a public property for it. Call that tileset. The getter is just simply going to return the local member variable. The setter, conversely, is going to set it. But then furthermore, I need to then set the picture box's image based on this new tileset. So to do that, I'm just going to go for tileset picturebox.image is equal to tileset.getImage from texture, which is our extension method that we created previously, so it may not show up immediately. So you may need to add the namespace for it. So control period on there, using the game editor.extensions, and there you have it. Furthermore, the tileset may potentially be null, at which point this will fall over. So we need to have a quick null check in there as well. So if the tileset is null, then what we want to do is set the tileset picture box's image to null. Else, we'll go about our business and set it based on the tileset. So now we can just go ahead and delete this image property, but not before we do some tidying up, otherwise it will make the designer a bit of a pain to work with, as it currently refers to it. So what we're going to do now is actually go straight to the designer on the form 1, right click View Designer, and in here I'm going to delete the Browse button, just to get rid of that. And then in the form 1 CS, we have a handler for the Browse button, so if I right click and view code, and then we have this handler for the Browse button, which I'm just going to go ahead and delete as well, as it's no longer needed. Okay, in the selected index changed, we have something that sets the image based on the tile set. What we now need to do is just pass the whole tile set to the tile set property and get rid of this here, so we no longer need the image specifically. So that now works. Give that a quick build, make sure that's all happy, so we fix the errors. And then over in the tileset previewer, I'm now going to remove the image property entirely. We may still get a designer error. Let's just take a quick look. So remove that, give that a build. So yep, here we go, we've got a designer error. What I'm going to do is just give that a quick clean and build again. So we've still got the error. So all we need to do is head over to this error here by double clicking on him. You may or may not have this error. If you do, this is how you fix it. So click on this error down the bottom here. Takes you to where it is. This is generated code by the designer. It's referring to the property which no longer exists. So all I need to do is just remove that check or remove that setting of null. Give that a rebuild just to make sure it's clean. And there you go, the build is successful. Okay, so we've removed the image property. We've now added a tile set property. Let's make sure it still sets the image on the previewer correctly. So let's give that a quick start. And then in the combo box, I'm going to select my mini tile set, and it does set the image as I expect. So that's all working. The next thing we need to do is start drawing our tile set frames over the top of the tile set image so you can see where they are on the tile set. And to do that is actually really quite simple. We just need to handle the paint event of the tile set picture box to then draw our frames over the top of the tile set's image. Now we have to handle this event and create the handlers for this event, slightly different to how we have done previously using the designer, because the picture box is embedded within a tile set previewer and thus isn't exposed to us in the designer. Furthermore, paint events are really flaky in the designer at best, so it actually makes more sense to do it this way. So to get us started, we're going to override a method on the tileset previewer called onCreateControl, and we're going to remove this call to the base. In here, we're going to do a quick check to see if we're not in design mode, which is a property of the component itself. And if we're not in the design mode, we're going to get the tileset picture box dot paint. And to handle this event, we're just going to type plus equals, and Visual Studio should give you a nice handy helper here, offering if you press tab to insert a handler for you, which I'm going to do. If you don't have that option, you just put in here the name of the method, and then the method itself accepts an object for a sender and a paint event args. So in here, we're just going to remove this call to the not implemented exception rather. And the first thing we're going to do is check to see if there is a tile set. If there is not, we're going to return out because there are no frames for us to draw, so that makes sense. The next thing we need to do is get the frames out of the tile set. Now the problem here is that we're dealing with two different types of rectangles, one being the MonoGame rectangle and the second being the system drawing rectangle. So we need to differentiate the two because they're both referred to as the same class name, which is just rectangle, albeit under different namespaces. To do that, we're going to add an alias at the top of the file here. And to do that, we're just going to type using MonoGame rectangle, so that's going to be the name of our MonoGame rectangle, believe it or not. And this refers to Microsoft.xna.framework.rectangle. Additionally, there's going to be the system rectangle, which is going to be system.drawing.rectangle. And you can see here where the confusion might come from if you're just calling them rectangle, because their namespaces are different, but the class names are the same. So you'll have to differentiate one or the other, whether it looks a little bit like this, or vice versa. Okay, so with them two defined, we know how to refer to them now. Down here, we're going to get a list of MonoGame rectangles, which are our frames, out of our tile set. So I'm going to call this frame rects equals tileset dot frames. Now we just need to loop through those rectangles to then start thinking about drawing them onto the tile set. So I'm going to go for a standard for loop, I equals 0 and a frame rects count I plus plus, and then we're going to pull out the singular rectangle. So MonoGame rectangle frame rect equals frame rects I. Okay. And here's where the issue then arises. We now need a system rectangle with the same content as this MonoGame rectangle. We could add an extension method which turns one into the other, but since this is the only place we're using it for now, we'll just go for it like this. So a system rectangle, we'll call this the drawing rect equals new, and then one of the constructors in here takes an x, y, width and height, so we just pass in those components of the frame rect. So we go for frame rect.x, frame rect.y, frame rect.width, and frame rect.height. Okay, so that's our drawing rectangle. Here is now when we need to start using it. So to draw the rectangle, we need to pull the event args e out, so e, and then there's an object on here called graphics, which we can then use to draw a rectangle. So the first argument of this is a pen, which represents the size and color of the border of the rectangle. So in here, I'm just going to go for pens.blue, and then the system rectangle is just going to be drawing rect. Okay? There you have it. So with that said, I'm now going to launch the editor, select my mini tile set, and you should see here 2 rectangles. You'll also notice that the border on the bottom and the far right is being cropped off slightly due to the nature of it drawing from the top left and the pixel border size. So what we need to do is take that into account when we're drawing the rectangle and reduce the width and height by 1. So if we give that a quick run once more, you'll see here if I now click the mini tile set, you can fully make out the whole of the tile. Okay, so that's about it for this particular part of this episode. What I'm going to do now is move straight on to the next episode, guys, so we can then get onto clicking the tiles and then subsequently painting them onto the map. It feels like this one's quite meaty as it is, so I'm going to cut this one a little bit short and then move on to the next one so we can go for 2 sort of average size episodes instead of 1 behemoth. So I hope you're all enjoying it so far. I hope you all appreciate the effort that goes into actually painting tiles onto a tile map if you want to do it sensibly. So I hope this is being really educational for you all. Thank you all for watching, and I'll catch you in the next episode. The next one will be uploaded alongside this one as well, so there'll be no waiting involved. I did promise you in the next upload you'll be able to paint tiles onto the tile map, and that will remain to be the case. I'm just splitting it into 2 smaller videos. Okay guys, thanks for watching. I'll speak to you soon.